Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep, and welcome once again to the GATE Champion Series. Yes, all GATE 23, GATE 24 aspirants aiming to be champions, toppers, rankers in the GATE examination. BYJU'S Exam Prep for you specially brought up this GATE Champion Series. So BYJU'S Exam Prep brought you the GATE Champion Series. Yes, let me again tell you that in this GATE Champion Series, we are discussing the more than 500 technical questions specific to your branch. And yes, wow, that's just like a book. More than 500 questions being discussed is just like a live GATE workbook for you. Okay, so this live GATE workbook covering different subjects of your branch, different topics of your branch. And today we are again here to discuss one of the very important topic of the electromagnetic theory, that is the antenna. That is the antenna, right? Yes, great. Okay, come on, quickly update all your friends that the session is live. Let everybody join. Students are joining, but little slowly. Very good evening, Dreamer, Alankar, Ravi Shankar. Very good evening, all. Let's get started. In case somebody new to my session, this is a brief intro about me. This is Rakesh Talreja, and I have secured All India Rank 9 in the GATE examination from Electronics and Communication, and I have completed my Masters from the Indian Institute of Science, Bangalore. Right, these are my major area of expertise for more than 12 years now. Good evening, Karan. Good evening, all. Yes. Right, and yes guys, just a few more months to left for GATE. Now only probably 4. When we started this it was 5. So on the BYJU'S Exam Prep app, we are also running a GATE Achievers series. So some very important topics of GATE 23 discussed on Wednesday, Thursday and Friday. I'll tell you, Wednesday concept class, Thursday previous year question discussions, and Friday is the quiz discussion of the first and second class, and Saturday you have some non-tech class also, right, like maths and aptitude. So register here for the GATE Achievers series that is happening on the BYJU'S Exam Prep app. And once again guys, on the BYJU'S Exam Prep app, this Tuesday, that is just tomorrow at 8 p.m. Tomorrow, Tuesday at 8 p.m, Fanindra Sir brings you an important workshop, how to ace the GATE with college or job. Yes, many students are confused about that, whether they can crack the GATE with college or exam. If yes, how? If not, what are the ways to overcome the hurdles you are facing, right? Definitely it's possible, but those who feel not, then you have ways to overcome. So join live tomorrow, and this is again on the BYJU'S Exam Prep app. The app is available on the Google Play Store. Download it and just register for this particular event. First question for the day. So guys, we have had the discussions of electrostatics, magnetostatics, wave propagation, transmission line and waveguides in this particular EMT, in the GATE Champion series in EMT. But today, coming to the most important topic, that is antenna. Okay, I feel students are little slow in joining. Is it that don't you want antenna? I think it is the one area where almost question is 99% probable, 99% probability that you'll get a question. Okay, let's see the tempo of the student. An antenna can be modeled as an electric dipole of length 4 meter at 3 gigahertz. If the current is uniform over its length, then the radiation resistance of this particular antenna. What do they want? They want the radiation resistance of this particular antenna. Radiation resistance of this particular antenna. Now, how you are going to figure out this problem? Try to understand. There is a length 4 and the frequency. Frequency is 3 megahertz. So, what is going to be the wavelength? Wavelength we calculated as C by F, and C is 3 into 10 power 8 divided by frequency is 3 megahertz. So lambda is equal to precisely 100 meters. Okay. Now the length of the dipole is given to you as 4 meter, and if you compare with the wavelength here, good evening Janvi, it is lambda divided by 25, because wavelength is 100. So 100 is divided by 25 will give you 4. Okay, so length is equal to lambda by 4. What I can say here is length is lambda by 25, which is less than lambda by 10. And whenever any current element, any dipole element having the length less than lambda by 10 is classified as a Hertz dipole, a very small current element. So we can consider this as the case of the Hertzian dipole, dear. We can all consider this case as the Hertzian dipole. And for the Hertzian dipole, what is the radiation resistance formula? Very simple and yet very important question. 80 pi square dl by lambda whole square. dl by lambda. dl means the small differential length that you have. So 80 pi square dl by lambda whole square. This is the important formula. So what is the radiation resistance? Let's quickly calculate. So it becomes 80 pi square into dl. dl ka value kitna hai? The length is equal to lambda by 25 and cancelled by lambda. So 1 upon 25 and then whole square. 80 pi square 1 by 25 whole square. Just calculate and get hold of the answer. Right? Calculate and get hold of the answer. Let's complete the calculations here quickly. Yeah, it's 1.28 nearly, right? It turns out to be 1.28, yeah, 1.26. Okay, so option number B. Option number B. Okay. So approximately it would be turning out to be 1.26 ohms. Perfect. Yes, Ravi, correct. Next question ready for you. Okay, a dipole with a length of 1.5 meter operates. A dipole with a length of 1.5 meter operates at 100 megahertz while the other has a length of 15 meter and operates at 10 megahertz. Okay, they are both fed with the same current. What is the power radiated by the two antennas? The radiated power is I square R. Which I? The peak value of the current, but that is same into radiation resistance, right? So I naught to same hua. What about the radiation resistance? Now let us see. A dipole with a length 1.5 and operates at 100 megahertz. We'll do the same activity, guys. From the frequency, we'll calculate the wavelength lambda, and then we will see the length is how much portion of the wavelength. Okay. So first case, you have the lambda 1, which is C by F1, and that is 3 into 10 raised to the power 8 divided by frequency is 100 megahertz. 110 power 6. So lambda 1 is 3. And whereas what is the first length given to me is 1.5 meter. And that is here lambda by 2. Okay. Now, what about the second one? So here length is lambda by 2, which is not less than lambda by 10. Second case, the lambda 2 will be given by 3 into 10 power 8 divided by the next frequency. The next dipole is operating at the frequency of 10 megahertz. So this becomes 30 meters, right? And what is the length 2 given? What is the L2 given? There's a length of 15 meters now. Okay, and this is again lambda by 2. Right? And for length equal to lambda by 2, you have a dipole antenna. Right? For both of them, length is lambda by 2. So both of them are dipole antennas. Which dipole antennas? Half wave dipole antennas. Both are known as half wave dipole antennas. Both are similar. They have the half wave dipole antenna. And what is the radiation resistance for half wave dipole antenna? Guys, what is the radiation resistance for half wave dipole antenna? Is given by 37 ohms. It is given by 37 ohms. Approximately it is 73 ohms. Reading it reverse, I don't know. It is 73 ohms. Approximately it is the 73 ohms. Okay, dear. Okay, now what is the radiated power? That is half I naught square R rad. Right. Half I naught square R rad. Half I square R. Oh, sorry. Half I square R if I am considering the peak current. Sorry. Okay. So now this is also same. This is also same for both. Okay, so radiated power will be same for both. So both antennas radiate the same power. Option number B is the very correct answer. Okay, yes, streamer Ravi Shankar. Yes, Karan. Option number B is the correct answer. Take it here. Option number B is the simple and correct answer here. Moving to the next question. Okay, let's come here. the radiation intensity. Now coming to a very important question, radiation intensity of antenna has been given. Determine the directivity of the antenna. Some very important formulas we will revise here. Some very important formulas we will revise here. Directivity पूछा है. Okay. So now let us have a revision of the formulas related to it. Some formula related to this, some formula related to the upcoming question. तो देखो, what you have to do, the power that is radiated by any antenna, we all know that the power is evaluated by surface integral of time average pointing vector. We have solved these questions also in the wave propagation class. It is the surface integral of the time average pointing vector, which is P average. ये हो गया radiated power. Okay. Now this is further written as, okay, for any antenna, the radiated power is in the radial direction and the ds in the radial direction, r square sine theta d theta d phi. This is next formula to calculate the radiated power. Now out of this dear, we call the P average into r square as the u theta phi, which is known as the radiation intensity, the parameter that is given in this question. I'm just making a quick revision. We are not going into detailed discussion because we need to solve the questions and revise the chapter. Sorry, this is known as the radiation intensity. Okay, that is what is given, radiation intensity. Okay, u theta phi. Sine theta d phi is known as the d omega, differential solid angle, is known as the differential solid angle. So that we can write down this one as, u theta phi d omega. Okay. This is the radiated power. Now, we'll come back to the question. Let us quickly solve and revise the other things. Now, let us define the directive gain. Let us define the next important quantity, that is known as the directive gain. Okay. The directive gain of the antenna, GD theta phi, is defined as the radiation intensity of the antenna divided by the average value of the radiation intensity. Okay, acha. Now we know that radiation intensity is u theta. Average radiation intensity after calculating has turned out to be P rad upon 4 pi, radiated power divided by 4 pi, so that the final formula for the directivity, for the directive gain of the antenna will become 4 pi goes to the numerator, 4 pi u divided by P rad. Let me simply write u. It's a function of theta phi, we all know. Or this can be written as 4 pi. What is radiation intensity? R square P average. This portion, R square into P average. Okay. R square P average. What is the P average? Time average pointing vector. Time average power flow of the wave is divided by the radiated power. This is yet another next important formula for you. Right. This one is also important. This is the very basics of wave only, we all know. Okay, now directive gain ke baad, let us also revise the directivity. What is the directivity of the antenna? The directivity of the antenna, referred to as D, is known as the maximum value of the directive gain. It is known as the maximum value of the directive gain. Okay, and the maximum value of the directive gain can also be written as, this is 4 pi u upon P rad. This can be written as 4 pi u max divided by P rad. Okay, so this is the next important formula for you. Okay. Next important formula for you is the radiation efficiency. We will take up question on all of these. Radiation efficiency. Radiation efficiency is written as eta R, and that is given by the power radiated by the antenna divided by the power that is input to the antenna, and it is also known as GP upon GD, where GD I told you is a directive gain. GP I told you is a directive gain. The GP is known as the power gain of the antenna. It is also given by one more formula, right? Eta R is also given by one more formula, that is the radiation resistance divided by the radiation resistance plus loss resistance, RL. RL is known as the loss resistance of the antenna. Okay, this is the next important parameters for you, that is the radiation efficiency. Chalo. Now for a moment, let's turn back to the question also. Question mein radiation intensity given, they want the directivity. Okay, they want the directivity. Now listen to me. How do you calculate the directivity? First, I should be calculating GD, that is the directive gain. Okay, that is the directive gain. Yeah, chalo, see the directivity likhte. Directivity, as I told you, it is the GD max, and that is equal to 4 pi U max upon P rad. That is the formula we discussed just now. 4 pi U max upon P rad. Sir, what is the U max? What is the U max? The U function is, everybody, it is sine square 2 theta. Right? For theta between 0 to pi, phi between 0 to 2 pi. What is the U max? What is the maximum value of sine theta is 1, na? So maximum value of U is also equal to 1. So U max is also equal to 1. We are very sure about this. U max ka value 1 ho gaya. Right? At 2 theta equal to 90, theta equal to 45, which is in the range. Okay, so U max to 1 ho gaya. Okay, next is, the next important thing is the radiated power calculation. For this, I will have to do some calculations. Here, I will need a little bit of the effort. Here, we need a little bit of the effort. So, what is the radiated power? Let us calculate here, everybody. What is the radiated power? As I told you, it is double integral U d omega. That is double integral U is given to you as sine square 2 theta d omega. D omega already I told you is known as the sine theta d phi. Okay. So what is the radiated power, dear? It is given by double integral sine cube theta. This becomes sine cube theta. No, sorry. Sine cube theta, and that is sine square 2 theta. Right. So 2 ka square ho gaya 4. 4 sine square theta sine theta, so sine cube theta, and cos square theta d phi. Limits of theta 0 se pi. Theta is 0 se pi. Phi is equal to 0 se 2 pi. Complete. Okay, now let us complete this calculation. 4 sine power m cos power n. I will directly use the Wallis integral formula. Right. The techniques of integration I have taught you in the earlier classes, even in the YouTube also. I have taken sessions on differential calculus. I have taken sessions on integral calculus. Okay, so let's just use that. The answer will be given by 3 minus 1, that is 2 double factorial, which is 2. 2 minus 1, 1 double factorial, divided by 3 plus 2, that is 5 double factorial, so 5 cross 3 cross 1. Okay, m minus 1, n upon m plus n, and both the powers are not even, so this will be equal to 1. Right, so it becomes 8 is divided by 15. 8 divided by 15. Now the directivity, which is 4 pi U max upon P rad, just substituting the value, this becomes 4 pi U max ka value, already we have written this to be 1, divided by 8 is divided by 15. Okay. So after the calculations and all, this is 2 cancel, this becomes 15 going above, 15 pi by 2. Options are in the, okay, let's calculate this. Dear, let us calculate this. $23.55. No. 15 pi by 2. Yeah, 15 goes above. The radiated power is 8 by 15. Correct. Theta pi by, oh, sorry. Yahan pe there are slight changes, I think. I have done the calculation mistakes in hurry berry. Okay, ye ho jayega. First of all, d phi ka integral phi, and the limit of phi separate 0 se 2 pi, and then coming here sine cube theta cos square theta, that to 0 se pi. So twice integral 0 se pi by 2 will come, and then I will write down the answer. Then I will write down the answer that I have written. 2 1 divided by 5 double factorial 531 and whole multiplied by 1. Yeah, this should be the better answer. So 4 2s are 8, 16. This is 32 pi actually divided by 15. Okay, a small correction here, guys. 32 pi is divided by 15. 32 pi is divided by 15. Okay, 32 pi is divided by 15. 32 pi is divided by 15, and now this is 15 and divided by 8. 15 divided by 8, that is 1.875. We have that option? Yes, we have that option. 1.875. 1.875. Option number A. 1.875. Yes, Ravi, correct answer. 1.875. Okay. Chalo, yes, Karan, correct. 1.875 is the very correct answer. Okay, dear. Chalo. And with this, we have some very important formulas that we have revised. Some very important formulas we have revised. And if you have understood, because this is an important type, so especially, see, we are not much discussing PYQs in this session. I have brought you fresh questions other than PYQ for your practice. Sometimes 1 or 2 PYQ, and I'm not solving this. This is the question related to it. I want to give you this as a homework to try this gate 2-mark question. Same, what is given to here is, you are given W average. W average is nothing. Power. Ultimately, they have told power density. So this W average is nothing but the P average. What we call it as P average. Time average pointing vector. Time average power density of the wave. Right. If you have understood the question, you should be able to solve this question. They want the radiated power. We have calculated that also in the previous question, and the directivity of the maximum directivity. Here maximum word is irrelevant because directivity means always maximum directive gain. Okay. If you have understood the previous calculations and if you have revised the previous formula like this, that question should be achievable, and those are 2-marker level of the gate, and that is why I want to give you that as a homework so that you try this. So this is the homework for the night. Next question. Determine the electric field intensity at a distance of 10 km from an antenna having a directive gain pe 5 dB and radiating a total power. P rad is given to you 20 kilowatt. Acha. Now, sir, what they have given? They have given the directive gain, but in the form of decibel, not the absolute directive gain. So decibel means 10 log GD, because these are gains, power gains. So we use 10 log. 10 log GD is 5 decibel. What is the GD? That becomes 5 by 10 half, 10 raised to the power half. That is under root of 10, and nearly this is 3.16. So GD has been given to you as 3.16. You need the what? Electric field value. Now, what is the GD formula? Let us come and use the GD formula. GD is 4 pi R square P average. 4 pi R square P average divided by P rad. 4 pi R square P average is divided by the P rad. Okay. Now, we have the GD, which is 3.16 is equal to 4 pi R. R is the distance given hai kya? Yes. I want this at a distance of 10 kilometer. So R is 10 kilometer. Okay, that is 10 raised to the power 4 meter. Kilometer is 10 power 3, na? Okay, so R is 10 raised to the power 4, and R square multiplied by P average can be obtained here, divided by the radiated power jo ki given hai 20 kilowatt, to 20 into 10 power 3. Okay, let us all work on calculate this P average from here. Let us calculate the P average from here, everybody, and if you complete the calculation, please give me the answer without any hesitation. Yes. So P average turning out is somewhere around 12.58 into 10 raised to the power minus 8. That will become 10 power minus 8 watt per square meter. But I don't want the P average. I want the electric field. So what is the relation? P average is given by mod E square divided by 2 eta. So what is the mod E square? It will be equal to P average, which is 12.58 10 raised to the power minus 8 into 2 eta. Eta for the free space is 377. Right. So this much is turning out to be 94.85 into 10 raised to the power minus 6. This is the mod E square. So what is going to be the modulus of E? What is going to be the modulus of E? Just one last sub calculation. What is the modulus of E here? 9.74 nearly. 9.74 into 10 raised to the power minus 3 volt per meter, or I can say 9.74 millivolt per meter. Just check out the calculation quickly. Just check out the calculation, guys, once quickly. Okay. Just be sure with the calculations. GD was given to be 5 by 10, correct, 10 raised to the power half, which is root 10. So यहाँ तक सब perfect था. नहीं, एक बार रीचेक करना पड़ेगा गाइस. कैलकुलेशंस काइंडली रीचेक एंड असिस्ट मी इन द, यार कैलकुलेशन में तो यू गाइस शुड असिस्ट मी यार. आई एम नॉट हैविंग दैट वर्चुअल कैलकुलेटर आल्सो राइट नाउ. This should be 50.29. This is actually 50.29 10 raised to the power minus 6. 50.29 10 raised to the power minus 6 watt per square meter. Okay, 50.29 10 raised to the power minus 6. Yeah, 0.194. So after solving all the particular calculations, yes, I've just tallied the calculations. Mod E, the magnitude of electric field is turning out to be 0.194 volts per meter. 0.194 volts per meter. Dreamer is very correct. Yes, Dreamer is very correct. Okay, so just guys, you have your virtual calculators, GovGate available live. Just keep on doing it. Okay, 0.194 volt per meter. Correct answer. Important type of question it is, but based on the basic formula of directive gain. Based on the basic formula of directive gain. Okay. Chalo guys, moving to the next question here. Yeah, moving to the next question here. A lossless antenna with a directive gain of 6 dB, has having a directive gain of 6 dB. If 1 milliwatt of power is fed to it, what is the power radiated? Guys, what is lossless antenna? Lossless antenna is one which is having the 100% efficiency. There is no losses, right? A lossless antenna is one which does not have any lost power, and so that whatever is the power you input to the antenna, it is the radiated power plus P loss in general. The power you input to the antenna, portion of it is radiated into the atmosphere, into the space, and a portion of it is lost. But if I take it as 0, I get P in equal to the P rad. Okay, right. And that is why when we talk about the efficiency, efficiency is known as radiated power divided by the input power, but because both are same, the efficiency is 1, or 1 means 100%. What is the power radiated by the antenna? Now, power radiated by the antenna is same as the power input to the antenna, and the answer is option number B, 1 milliwatt. This is a very basic fundamental question. The power radiated by the antenna will be power input to the antenna because it is a lossless antenna. Okay, it is a lossless antenna, or it is a 100% efficient antenna. Okay, so correct, is a very simple question. Correct answer is option number B. Now we have the next question here. The radiation resistance of an antenna is 63 and the loss resistance is 7. If antenna has a power gain of 16, then calculate the directive gain. So again, it is a question based on the efficiency, eta R. It is a question based on the efficiency, that is the eta R, and eta R is given by GP divided by GD, and it is also given by radiation resistance and loss resistance given here. So in terms of resistance, it is given by R rad upon R rad plus RL. There are three definitions, three formulas we have seen, na? Okay. Radiation efficiency, P rad upon P in, or also GP upon GD, or also the last formula. All of this we have revised. Good evening, Payash. Okay, so now let us use the last relation. So what is the GP? It has a power gain of 16. Calculate the GD. Calculate the GD, and the radiation resistance is 63. Loss resistance is 7. Okay, loss resistance is 7. Okay, so what should be the value of GD from here? what is going to be the value of GD? Let us see this number. We have this actually 0.9 and we have 17.77. So 17.77, yeah, 17.78. But options are in the form of decibel, right? In decibel, it should be 10. Take the 10 log of this answer. Take the 10 log of this answer and conclude in front of us quickly. It is 12.49 or 12.5 approximately. 10 log 17.78, answer is turning out to be 12.5, option number B. Important and simple questions. Important hai, but utna hi simple hai if you have studied the antennas from fundamental and with all formulas. Okay. ठीक है, done. Chalo. Next. A thin dipole antenna is lambda by 15 long, lambda by 15. Length is lambda by 15, which is less than lambda by 10. So it is again the case of Hertzian dipole. Right. Loss resistance given. What is the efficiency? So efficiency is what? Guys, you can complete this question as a homework because efficiency is given by Rad is divided by Rad plus RL. RL is given to you. You need to calculate Rad. And what is the formula for Rad? Hertz dipole formula 80 pi square dl by lambda whole square. 80 pi square dl by lambda whole square. Right. Okay, Gajendra. After EMT, EDC will be starting, but by Sanjay Rathi, sir. EDC will be starting, but that is by Sanjay Rathi, sir. Okay. So 80 pi square dl by lambda whole square, you calculate the radiation resistance and complete the answer. A small homework for you. Almost the hint has been given to you and they have given in the form of percentage. Multiply by 100 at the end. Okay. Since it is given in the form of percentage, you can multiply by 100 at the end. Okay. Next. An antenna has a power input of 40 pi and the efficiency of 90%. The radiation intensity has been found to be a maximum value of 150. Determine the directivity. Okay, directivity. Acha. Directivity once again is the maximum directive gain, GD max, and that is given by 4 pi U max upon P rad. Ab dekho. U max is given to you, right? We only need the P rad and efficiency is given to you. Efficiency given hai na, efficiency of 90%, but this efficiency is the radiated power upon input power and input power is given to you. Okay, so can you calculate the radiated power? Yes, sir. What is the radiated power? It is the efficiency. It is the efficiency into the input power. Now it is just one calculation away. 4 pi into maximum value of radiation intensity. What they have given? Radiation intensity ka maxima, that is 150. So this is 150 is divided by eta R. Okay, that is 0.9. 90% into fraction 0.9 and radiated power is 40 pi. It is 40 pi. Right, guys, let's quickly come up with the answer. Let us quickly come up with the answer. Yeah, 16.67. This is turning out to be 16.67 or 50 by 3 to be precise if I solve it in terms of fraction. 50 by 3. So that is 16.67 only. That is a 16.67. Correct? Correct. Okay. Yes, Dreamer and Karan Gupta, correct answer. That is a very correct answer. Okay. Next question ready for you, sir. Okay. Yes. Next question is ready for you. An antenna is operated, it desired to operate on a frequency of 40 megahertz whose quality factor is 50. Determine the bandwidth. Okay. What is the formula for the bandwidth? The bandwidth of the antenna is given by operating frequency divided by the quality factor. Divided by the quality factor. So calculate this answer here. Bandwidth is 40 megahertz. 40 options are in form of kilo or mega. Check kar lenge. 40 into 10 raised to the power 6 divided by quality factor, which is 50. which is 50. So this is 0.8 and 8 wala option kilohertz mein hai. So of course 0.8 into 10 power 3, 800, rest is 10 power 3 left. 800 kilohertz is my answer, option number B. A direct formula based question. Option number B, 800 kilohertz. That is the 800 kilohertz, option number B. That is known as the 800 kilohertz and that is the option number B. Right, dear? Chalo. Next. Let's come here to the next. An antenna has its electric field given to you. Its HPBW is. Find its HPBW. What is HPBW? HPBW is known as half power beam width. Half power beam width. And how do you calculate this? This is calculated as angular separation. Right, angular separation between the 3 dB between the 3 dB points about the maxima. About the maxima. This 3 dB itself is half power. 3 dB itself is half power. Either you call it as half power or 3 dB, it is one and the same thing, right? Because when you take the 10 log, because when you take, suppose the power becomes half of the P. If initial power is P, power becomes half. 10 log half is minus 3 dB. So whenever power becomes half, there is a drop of 3 dB. There is a drop of 3 dB. Okay, there's a general drop of 3 dB. Okay, now how do you find the angular separation here? Okay, what is the electric field pattern given to me? That is E naught square, that is E naught sine 2 theta, right? What is the power pattern then? Okay, what is the power pattern? Okay, power pattern depends on P average, and what is going to be the P average? P average is known as mod E square by 2 eta, right? So that is E naught square sine square 2 theta divided by 2 eta. E naught square by 2 eta is just a constant, no? So this is nothing but some constant k into sine square 2 theta. When it is going to be maximum? When it is going to be maximum? Okay. So power pattern here, when it is going to be maximum? Maxima kab milega? When it is going to be maximum? So maxima at sine theta maximum value as 1. And that is occurred when 2 theta equal to 90 degree, that is theta is equal to 45 degree or pi by 4. Okay, pi by 4. And what is that maximum value of that function? The maximum value is k. Okay, now when does the power becomes half? Okay, when does the function, that is the power function, becomes half of the maximum value? Half of the maximum value matlab k by 2 sine square 2 theta, इसको यहाँ लिखते हैं f, which is k sine square 2 theta should be equal to k by 2. Half of maxima, maxima is k, right? So this is eventually giving you the formula sine square 2 theta should be half, or I can say that sine 2 theta is 1 by root 2. Sine 2 theta is 1 by root 2. So what is the 2 theta, guys? 2 theta 1 by root 2 कहाँ आता है? Either 45 degree or 135 degree. Theta is in the range 0 to 180, उसी का ध्यान रखते हुए. So it is either 45 or 135. So what is the theta then? Okay, what is the theta? Let's talk in terms of, options are in the form of pi. Let's talk in terms of pi. So this is either pi by 4 or 3 pi by 4. 2 theta is pi by 4 or 3 pi by 4. So what is going to be the theta? Divide further by 2. So pi by 8 or 3 pi by 8. Okay, this is the half power points. Now see, the situation is something like theta, we all know, spherical coordinate system theta, we have evaluated this theta with respect to z-axis always. The co-latitude is measured with respect to the z-axis. This is x-axis, y-axis, and the z-axis. Okay. The maxima was at 45 degree pi by 4. This is the direction of maxima. Maxima is there definitely at the 45 degree, right? Pi by 4. But then at pi by 8, okay, look into this calculation now. At the pi by 8 and at 3 pi by 8, right? Whether you take pi by 8 or 3 pi by 8, the power becomes half. What is the angular separation between these 2 points? That is known as HPPW. That is known as the HPBW. Okay, this angular separation, this is known as the HPBW, right? And that is given by 3 pi by 8 minus pi by 8. And that is pi by 4 actually. That is pi by 4. Arey, why these words are gone? 3 pi by 8 minus pi by 8. That is pi by 2. Pi by 4. What is HPBW? Pi by 4. Okay. So this is pi by 8. This is 3 pi by 8. Okay. Angular separation between the half power points, or I can say that angular separation between the 3 dB points. Between the 3 dB points. Angular separation between the 3 dB points, and that is known as, kitna aaya? Final answer is pi by 4. Final answer here is pi by 4, dear. Okay. So this is the HPBW for the given question. Now let me ask you some additional information. Let me ask you, what is the HPBW for Hertz dipole? Anybody? And what is the HPBW for a half wave dipole? Lambda by 2 dipole. What is the half power beam width for a Hertz dipole? Is 90 degree. For a lambda by 2 dipole, it is 78 degree. Right. For any other, we have to calculate just as the procedure followed here. Okay, we have to calculate just as the procedure which was followed here. Right, everybody? Okay. Full power तो कैसे होगा? Full power means only maxima ना Karan? Okay. चलो. This is what is HPBW. Next question. Next question. What is the next thing coming up here? The electric field strength impressed on a half wave dipole is 6 millivolt per meter at 60 megahertz. What is the maximum power received by the antenna? What is the maximum power received by the antenna? What is the maximum power received by the antenna? Okay. What is the maximum power received by the antenna? Chalo, let's have a look into this. The electric field strength imposed and now maximum power. Acha, what is the power received by the antenna? Dekho, in general, there is a concept of effective area. The effective area of an antenna is the power received by antenna divided by. It is the power received by the antenna. Now, why do we calculate this? Okay, why do we calculate this? उसका भी पूरा इंटेंट समझाते हैं हम लोग. उसका ही पूरा इंटेंट समझाते हैं. Okay. We need to compare the power that is received by the antenna against what is the power, time average power density, which is incident on the antenna. Okay. And a measure of it is the effective area. A measure of it is the effective area. A measure of it is the effective area. Now, the electric field strength impressed on a half wave dipole is 6. Electric field ka strength given hai. Mod E is 6 millivolt per meter. So, can I calculate P average here first of all? P average we all know is mod E squared divided by 2 eta. So, 6 into 10 raised to the power minus 3 ka whole square divided by the 2 eta. Let's just quickly compute this number. Right. So this is the one maxima, sir. Which maxima, Karan Gupta? Please specify your doubt once clearly. Okay. So this is 0.0477 into 10 power minus 6 watt per square meter. Okay. watt per square meter. This is the P average. Okay. Now, effective area को maximize करना है. Now, what is the other formula for the effective area, guys? Learn the next formula for effective area. Effective area is also given by, dear, effective area is also given by the formula lambda square by 4 pi into GD. GD is the directive gain, and hence maximum effective area of an antenna is given by lambda square by 4 pi GD max. Lambda square by 4 pi GD max. Okay, these are both important formula. Now, I want the power that is maximum. Okay, I want what is the power, maximum power received by the antenna. So, what is the maximum power received by the antenna? For the maximum power reception, the effective area should also be maximum. So, this represents AE max multiplied by P average. P average हमने calculate कर लिया है. What is the AE max now? What is going to be the AE max? GD max means the directivity. And what type of dipole this is? What type of dipole? Half wave dipole. What is the directivity of half wave dipole? Can you quickly comment and tell me? Okay, Karan, great to know that you got the point. What is the directivity of half wave dipole antenna? Okay. So eventually यहाँ पे directivity ही लिख देते हैं ना. Let me just write down here D only. GD max, which is eventually directivity, we all know. Okay. So this is how much lambda. Lambda निकालेंगे. Frequency is given to you. So what is the lambda here? 60 megahertz है ना. Right. What is the lambda? It is C by F, 3 into 10 power 8 divided by 60 megahertz, 60 into 10 power 6. So 300 by 60 becomes 5, lambda 5. Yes, anybody? Directivity? Guys, waiting for you. Okay. This is nearly 1.64. This is nearly 1.64. Correct, dreamer, correct answer. It is 1.64. Now, these are all the values. See, some values which are important you remember. Otherwise, we calculate. So, यहाँ पे आ जाते हैं. What is the lambda square by 4 pi here? Lambda हमने निकाला 5. So, 5 square divided by 4 pi into directivity of 1.64 is whole multiplied by the P average, which is 0.047. Into 10 raised to the power minus 6. Okay. What is the maximum power received? We need the answer in nanowatts or microwatts. Check कर लेते हैं जिसमें भी आ जाता है. Everybody, let us just complete the calculation here. Okay. Yes. 10 power minus 6. Perfect. 0.155. This is nearly 0.155. 10 raised to the power minus 6 watts. Okay. And we need in nanowatts. So this is 155. 10 power minus 9. That is nanowatts. 155 nanowatts. Option number A, dear students. It is the option number A, 155 nanowatts. 155 nanowatts. ठीक है, 155 nanowatts. चलो. Next question ready for you. Two half-wave dipoles are placed. Two half-wave dipole antennas are operated at 100 megahertz and are separated by 1 kilometer. The separation is 1 kilometer. If 100 kilometer watt is transmitted by one, 100 watt is transmitted by one, what is the power received by another? So, who gives the relation between the power transmitted by one antenna and the power received by another antenna which is in the far zone of it? That is given by what equation? That is given by a formula known as the Friis transmission equation. That is given by the formula known as the Friis transmission equation. So what is that Friis transmission equation? The power received by a receiving antenna is given by GDT, GDR, lambda divided by 4 pi r whole square into PT. PR, power received. GDT, GDR. GD means directive gain. Directive gain of transmitter. Directive gain of receiver. Right. Lambda is the wavelength. 4 pi r. R is the separation. And PT is the power transmitted. Okay. So see, two half-wave dipole antennas are given. Two half-wave dipole antennas are operated. And what is the power received? So what is the directivity? What is the directive gain you will use? What is the directive gain you are going to use? It's 1.64. Of course, the maximum power received aa jayega yahan pe. Lambda is given to you, no, frequency is given to me. So what is the lambda? 3 into 10 power 8 divided by the frequency of 100 megahertz. So this becomes 3. Lambda ho gaya 3. Okay, R is given to me, PT is given to me. So let us just calculate the number. So what is the power received? Both are same antennas. So both their directive gains is same. GDT GDR into lambda. Lambda kitna aaya? 3 is divided by 4 pi R. R hai 1 kilometer. R hai 1 kilometer, 10 raised to the power 3 whole square into the PT. That is 100. That is 100. Okay, let's just quickly calculate and close this calculation. Okay, so how much it is? 0.153 into 10 raised to the power minus 4 watts PR. 0.153 10 power minus watt मिली के फॉर्म में है और माइक्रो के फॉर्म में है, माइक्रो के फॉर्म में भी है, राइट. सो इफ आई मल्टीप्लाई दिस इज multiply by 100, 15.3, and then it becomes 10 power minus 6 microwatt. 15.3 microwatts is nearly 16. Okay, it is nearly 16. It is nearly 16, the final answer. In microwatts, the microwatt, it is nearly 16. Okay, just check up the calculations one as a backup. Just check up the calculation part once. Okay, guys. Do check up the calculation part once. Okay. Next question. Antenna array. An array comprises of two dipoles that are separated by the wavelength. The dipoles are fed by current of same magnitude and phase. What is the array factor? What is the array factor? What is the general formula for the array factor? So let us just come back and revise here. What is the general formula for the array factor of an antenna? That general formula is given by magnitude of array factor given by modulus of sine n xi by 2. That is the next important question here. Divided by sine xi by 2. Modulus of psi n xi by 2 is divided by the sine xi by 2. Right. N is the number of elements. N is known as the number of antenna elements used. N is the number of antenna elements. And what is xi? Xi is given by the formula beta d cos theta plus alpha. Beta d cos theta plus alpha. Right, where d is the separation between the elements. Separation between the elements, which is usually fixed, right? And alpha is the phase difference between the currents. Between the currents phase to them. All the currents are commonly fed with the same magnitude. There is a phase difference, and that is alpha, right? Okay. Radiation pattern is given by radiation intensity. We have taken as U theta, Rahul. Okay, radiation pattern is a sketch of radiation intensity only. Radiation intensity is a mathematical way of talking about the radiation of antenna, and radiation pattern is a pictogram way of talking about the radiation, Rahul. Okay, chalo. So xi is beta d cos theta plus alpha. Okay, now how many number of elements are given here? How many number of elements are given here, and what is going to be the value of xi? As I told you, xi is beta d cos theta plus alpha. Okay, the currents are of same magnitude and phase. Same phase is there. same phase, matlab alpha 0. They are of same phase. Okay. Because the currents are of same phase, matlab there is no phase difference between them, alpha is 0. Right? Alpha is 0. And they are separated by the wavelength. So D is equal to lambda. D is equal to lambda. So xi becomes beta. What is the formula for beta? 2 pi by lambda. D is lambda multiplied by cos theta plus alpha. Alpha is 0. Okay, so lambda lambda cancel. Xi is just equal to 2 pi cos theta. Okay, acha, now what is the array factor then? We know that array factor is given by modulus of sine n xi by 2 divided by sine xi by 2. But we are dealing with two antenna array here. Two antenna element here. N ka value 2 hai. And if the n is equal to 2, modulus of array factor after solving, dekho, it becomes sine xi. Okay, you will use the property 2 sin theta by 2 cos theta by 2. You are going to get cos theta by 2 only. 2 cos xi by 2. 2 modulus cos xi by 2. यहाँ पूरा ही लिख देते हैं. Mod 2 cos xi by 2. Okay, using the formula of sin theta as 2 sin theta by 2 cos theta by 2. Okay, so just complete this answer. अच्छा, यहाँ तक भी याद रखना because there are two antenna question important. Two element array, two antenna array important है separately. So what is the modulus of array factor now? It is 2 cos of xi by 2. Xi is 2 pi cos theta. Xi by 2 will become pi cos theta. 2 cos pi theta ka modulus. Okay, so the answer is 2 cos pi cos theta. 2 cos pi cos theta. Actually modulus bhi hona chahiye, but that is okay. Option number D matches here. 2 cos pi cos theta. 2 cos pi cos theta. Now, next question related to it. We have a next question related to it. Okay, the nulls of the pattern will occur where? The nulls of the pattern. The nulls of the pattern, same question hai, occurs given by the formula n xi by 2 is equal to k pi or plus minus k pi, where k is equal to any integer. Okay, but it should not be a multiple of. K is any integer, but not a multiple of what? It should not be a multiple of n. N kitna hai yahan pe? 2 hai. This is the general formula I have written. It should not be a multiple of n. So yahan pe, here, what is the value of n? The value of n is 2, right? So you have n xi by 2. You have 2 xi by 2 is equal to plus some issue plus or minus k pi. Plus or minus k pi. Okay. But where k is equal to how much? K is equal to 1. K is equal to 1. Any integer but not a multiple of n. N kitna hai? 2. Multiple of 2 means 2, 4, 6 nahi hona chahiye. So 1, 3, 5, 7, etc. Okay. So xi is equal to plus minus k pi. I will equate, और k का value अगर हमने रख दिया 1, तो plus minus pi or plus minus 3 pi or etc. What is the xi? Xi we calculated for the previous question, 2 pi cos theta. Okay, so we have 2 pi cos theta equal to plus minus pi plus minus 3 pi etc. Pi to pi cancel karte, divide by 2 as well. Cos theta is plus minus 1 by 2, right? Cos theta is plus minus 3 by 2. That is not possible. Okay. 3 by 2 is not possible. Okay. So केवल एक ही root आएगा 1 by 2 because cos theta cannot be greater than 1. So how much is the theta? Theta 1 by 2 is occurred at 60 degree or 120 degree. Second quadrant में cos is negative. Okay. Plus minus 1 by 2 or that is equal to, that means 1 by 2 or minus 1 by 2. Theta is 60 or 120 degree. 60 or 120 degree. Option number B. Option number B. Rahul, because k should not, that's what I told you, k is any integer, not a multiple of n, and here for this question n is 2. So it should not be a multiple of 2. Multiple of 2 is even number, so it should not be even. So obviously it is odd. It is odd. One more question based on the same. What is the maximum of the pattern? So maximum occurs where? What is the formula for maxima? maxima occurs either at xi equal to 0 or plus minus 2n pi, where n can be any integer. N can be any integer. Out of that, the principal maxima is known as xi equal to 0. So where do the maxima occurs here? Where do the maxima will occur here? Okay, xi, which is 2 pi cos theta. Xi is the 2 pi cos theta, and that should be 0 or plus minus 2 pi. Arey yaar, something, this board is not responding. Plus minus 4 pi. Arey yaar, God, what is happening? Etc. Okay. So what is the cos theta equal to then? Cos theta is 0. Divide by 2 pi. So divide by 2 pi. So plus minus 1. Okay. Divide by 2 pi there. So it cannot be plus minus 2. So I stop here. So how much is theta equal to? How much is theta equal to? अब इसको सीक्वेंस में लिखें तो it is minus 1, 0 or 1. Minus 1, 0 or 1. So how much is theta? Minus 1, 0 or 1. Minus 1 at minus 180 degree. Right? 0 at 90 degree and 1 at 0 degree. Okay, so this should be the case. 0, 90 minus 180 degree. 0, 90 minus या plus or minus 180 degree. Both are okay. Okay, so option that is going to match here is option number B. The option that is matching is option number B. Yeah, dreamer, very correct answer. The correct answer that is matching here is the option number B. Option number B, 0, 90, 180 degree. 0, 90, 180 degree. Correct hai? 0, 90, 180 degree. Chalo. Chalo. One more question for you as a homework. One more question for you as a homework. Okay. A 6 element, I'll give you the hints. N is equal to 6. Okay. Separation is given to you. It is to direct maximum 60 degree of the end fire. Matlab the theta you have to take as 60 degree. Okay. And maxima bola hai. So maxima by default commonly take the principal maxima. And principal maxima occurs at xi equal to 0. So whenever question says that you need maxima at some value of theta. Okay, so maxima means principal maxima. Okay, then the progressive phase shift, that is alpha, required between the excitation, required between the current sources. In which question, Ravi? So it's a simple question based on xi. Xi is beta d cos theta plus alpha. Xi is beta d cos theta plus alpha equal to 0. Theta given, alpha given, d and beta related, you will have to find what? Okay, you'll have to find alpha. Alpha is not given, sorry. Alpha you will find. That's it. Simple homework question for you. It is a simple homework question for you. Next one. This one was a simple homework question for you. Okay. In an end fire array, there are 1000 elements equally spaced at a distance of quarter wavelength. At a quarter wavelength. What is the directivity of the antenna array system? See, we know the directivity of an antenna. What is the directivity of antenna array? It is given by the formula 4L by lambda. It is given by the formula 4L by lambda, where L is known as the length of the array. And how much is the length of the array? If there are 2 elements separated by D, okay, so the length is only D. If there are 3 elements, then the length is 2D. If there are 4 elements, then the length is total 3D. So if there are n elements, the total length is given by n minus 1 into D. The total length is given by n minus 1 into D. Correct? The total length is given by n minus 1 into D. Right? The length is approximately nd for large n. So see here 1000 elements are there. Here there are the 1000 elements. N, let's use the same notation that we have followed earlier also, capital N. So there are 1000 notations. Okay, so for large n, it can be directly written as n. Okay, n into D. Okay. So what is going to be the directivity then? What is going to be the length here? 1000 into D. D means the same, separation. And they are spaced at a distance of quarter wavelength. So ye ho gaya lambda by 4. So this is 250 lambda. Now directivity, as I told you, is given by 4L by lambda. That is 4 into 250 lambda divided by lambda is 1000. Is 1000. 1000 in decibel. It will be 10 log 1000. Log 1000, 10 power 3, 3 into 10, 30 dB. So this is 30 dB. This is 30 dB of directivity in decibel. Now, odd, see, K not equal to multiple of N only for which question? Only for the nulls question, Ravi, not for the maxima question. Okay. Chalo guys. All right. Okay, the password for today's PDF, that is going to be simple array. We discussed the last question on antenna array, ARRAA. Okay, although I found, this is a very important topic. Yeah, usually challenging. Many students have not even studied the theory of it. Maybe that is why. Many students may not have studied the theory portion of antenna. Maybe they are not right now interested for questions or what, I don't know. But especially for this session, I found a very low response. But still, I have covered my, part. More than 1 hour we have completed and good range of antenna questions completed. Right? Hopefully, when you complete the theory of antenna, maybe then you are looking into such questions. But we have covered a broad range of antenna question. So with this, I, Rakesh Talreja, signing off with this session and signing off for the EMT part also. Next subject will be taken as electronic devices and circuits. Very important, and already machines is going on by Ashutosh sir for electrical students. You are studying in the very fantastic manner. Those who are electrical, आप तो आज तो as EC का students है only, right? Now you are going to study EDC by Sanjay Rathi sir. That is going to start from Thursday or Friday. Stay updated to the channel, and you are going to study EDC by Sanjay Rathi sir. Okay. Radar is not in the GATE syllabus now. Radar is there for ESC. In the GATE syllabus, radar is removed. It is removed from 2021, Karan. Okay. Chalo guys, bye bye, good night, stay safe and take care of yourself. See you in some another session.